Hey guys, so in my last video, I installed PySpark so that way it's pre-populated within Jupyter Lab or Jupyter Notebook, whatever you want. And so now at this point, I'm actually going to show you how we can do some things in Spark, which is like the RDD functionality, which I'm going to spend maybe 10 seconds on, and then actual Spark data frames, and then maybe at some point how you want to convert those to pandas data frames. So the RDD is the basic functional unit of PySpark, right? So remember in Spark we have some driver, and then we have some driver node, right? This is our driver. And then we have a bunch of worker nodes, right? Because we're distributing this across multiple nodes, right? Like our work stack, right? This is how we're going to pump a bunch of data into Spark. So here's a driver, and then each one of these guys is a worker node. So RDDs are the basic functionality of this, but we're going to abstract away from that and get to the API, which means it's going to make our life even better. I put this simple RDD functionality in here just so that you guys could see it. I wrote, Kevin, I have a Python list, convert it to a Spark RDD. You just do sc.parallelize and boom, it becomes an RDD. Great, you want to work with RDDs, no problem. There's definitely some usage to RDDs, but pretty much all of Spark 2 and above, which is now Spark 3, everybody uses the DataFrames API the most, and every once in a while you'll get down to an RDD if you need to. So again, I said Spark RDD to Spark DF. Pretty simple, right? If I had an RDD and I wanted to convert it to a Spark data frame, it's a simple dot to data frame to DF. Very simple, very nice. But I think most of us, like myself, I have some massive CSV file that I can do nothing with locally. Like maybe I have like a 20 gigabyte, airline file, for example, and I can't work with it locally, so I actually need to run Spark within my Jupyter Notebook, and I'm going to read the CSV in. So I'm going to create a Spark, they call it like an entry point for an application, so I'm just going to import a Spark session, and then I'm just going to initialize Spark with a Spark session, give it an app name, analyzing crime data, and get or create. So it's just going to get or create this Spark session initially. Just kind of some setup configurations. So that's just the name of this application. And then I would do things like data. And so you can see that this is actually how I'm going to read in the data frame. So I have the format of the CSV. Yes, I have a header. And here is some local London crime data that I have. You can get the crime data, guys, and if you want to play along, go to this site right here. This is Jenny Revise Spark Introduction Data Frame data, which is nice. So like I got the London crime CSV from her at that website right there. So you can download it. It's like 900 megabytes. Again, it's not too big that you couldn't work on it locally. But at the same time, like it teaches you like how to do some basic introductions with Spark. So this is how I would like read in, format, option, and load, and got all those guys set up. Cool. And so a couple just methods and basic functionality, right? Like how do I count how many records there are? It loads pretty quickly for having, what is this, like 13 million rows. And then here's when I print the schema, right? And this is how I do a limit and a show. Every time I do a show, that is like an action on the data frame, so be careful because that actually populates like what needs to happen in Spark on the back end, and it can take some time if you obviously don't limit it or only show a couple records or something like that. So be conscious. Has a drop NA just like pandas does, which is nice. Like you won't even feel the difference. Has a dot drop, like, oh, I want to drop the LSA code. Fantastic, right? It's feeling exactly like pandas. You probably won't even feel the difference. The only difference I really feel from pandas initially is if you want to filter your data set, typically in pandas you just do df and then you just start filtering with like the column. Here you actually add the dot filter method, and then the rest of it is pretty simplistic, right? It's just like pandas at this point. A couple things that are different. Let's do some group bys, right? Like maybe I want to group by the borough name, and then I want to aggregate the sum, and this with column renamed is simply going to rename the column. Think SQL, right? Like I have an ugly sum column, and then I just want to rename it to whatever, so I rename it to convictions. And you could, a lot of people would typically chain a lot of these commands over and over. So you can see like here, I actually sum all the convictions together. And so from there, you're like, all right, well, maybe I want to make like a new column, like, like a percentage by conviction. So here's a couple of fun little things that you can do. I have monthly convictions, and I have data.filter. You can see that I'm filtering based on the year, and then I group by the month, I aggregate by the sum, and then I rename it as convictions, right? So cool stuff. Convictions by year, right? It's feeling very pandas based. The first thing you're going to notice is the total monthly convictions. When I actually sum all the convictions, when I do the ag and the sum, I actually have, it's actually a data frame. Keep in mind we're still in the data frame API, so I actually have to pull this 6 million number total conviction out. So this dot collect, remember, is an action. So I'm actually saying like resonate this data frame so that I can like do something with it, and then 0th row, 0th column. So again, that's just this number. So I'm just basically pulling the number out of this data frame, and then I want to divide all these convictions by this sum. So that's where you're going to get this with column method. That's a little bit different than pandas traditionally, right? In pandas, you just like write df column, and then you just do some like summations or subtraction. Here you actually have to say like with column. I'm going to name the column percent. Notice I did this func.round. Earlier I had imported .func somewhere. So like I was saying, I have percent, and I do this func.round right here. That's just because I imported this PySpark SQL functions as func. So rather than just having a round, you actually have to pull in the package func.round so that you can round the decimal places. Okay, so just a little bit of extra stuff you got to do. Right, so what I'm doing is conviction monthly convictions, right? So these guys that I had already done monthly convictions with Spark filtering, and then I divide it by the single number, which is total monthly convictions, and then multiply it by 100, round it to 2 spots. So from there, I noticed that month was looking like a string column, so I thought, oh, let's put this in a tutorial about how do we convert a string to an integer. It's not as simple as doing like dot as type as you do in pandas and then it just automatically converts. What you have to do is basically create a new column, but you just overwrite the month name itself. So notice that I have total monthly convictions with column month. So basically I'm saying make a new column, but overwrite the old name month, right? So my old name month is a string, total convictions monthly, right? So I'm just pulling out the column itself, month, and then I do dot cast integer type. Notice I had to pull that function in from PySpark SQL types integer type. And so that's how it ends up casting it back to my original data frame. So now month is now an integer. Now I can do something like order by total convictions month ascending. So I do from month 1 to 12, and I could also, order by, a million other things. Here, I'm just going to use the crosstab functionality, which is kind of nice. Like gives you like a little confusion matrix, like a pivot table, if you want to think of that from Excel. I'm just going to do data.crosstab. I want to go by borough, by major, crime category, and then this dot select. Think of that as subsetting your data frame to only the columns that you want. You can use dot select. It's just like in SQL, like where you use select. Rather than select star, you do select column 1, 2, 3. So I only want this borough major category is the concatenation of the crosstab borough major category. They smash it together. So I want to keep that first guy, and then burglary, drugs, and robbery are the 3 guys that I want to look at. And then what I do is I order by drugs descending. So I want the highest amount of drugs listed first, and so I can see that this guy Croydon had the most amount of drugs, and you can see that it's actually correlated with like burglary, but this is the only guy that's technically sorted. These other guys, you can see there's some mismatches in terms of sorting, but this guy is the sorted. And then luckily enough, let's say this is the data frame that you really want to work with to do some exploratory stuff. Like let's just go to pandas at this point. Look how small this data frame is. Like I think technically the data frame is only like at this point, I think there's only like 30 boroughs that I have here, right? So it's like 30 rows. So it's like, let's just work in pandas while we're here. Well, Spark is super awesome, and it can convert 2 pandas. Now, keep in mind that when I work with 2 pandas, right now in the Spark data frame, keep in mind, right, I have the driver and I have all the distributions of the worker nodes, right? So when I go 2 pandas, I'm going to lose all the Spark functionality. It's going to shove it into a single in-memory block, right? Of this is going to be pandas, right? This is pandas again. This is going to be a single block. For us, it's no longer a concern because our memory is so small, right? Like this data frame itself is like 33 records, right? Very small. But just keep in mind, like if you're trying to shove everything into pandas, you're going to lose the Spark functionality. If this guy is still 30 gigabytes, well, you're going to go to pandas, you're going to lose, you know, all the usage of Spark in the first place. But you can see now we have our nice, pretty pandas data frame that, you know, Jupyter Notebook resolves for us automatically. A couple things you can do. You can mess with matplotlib. So like, let's say you have our Spark transformations. So I want to go by year, the burrow, the sum, right? These are all things we've done, and then just rename the column. This local iterator, just take it as an iterator that allows me to grab, think of conviction sum by year. I think I had one up here. Yeah, so like I think I only have 2 columns in that data frame when I actually select them out. But that local iterator is basically going to grab a row at a time. Think of like df.iterRows is the way that I'm thinking of it, but it's a generator function, so it saves you some memory if you were to actually run this burrow list right here. This toLocalIterator is a generator function. So what it's going to do, it's going to pull out the month and the burrow count by convictions, like chronologically throughout your data frame. Mess with it if you don't get what I'm saying, like I had to as well. And then the rest of it is normal matplotlib. So now I have a bar of burrow lists and conviction lists, right? So this is normal matplotlib, plt.bar, add a title, and then I just run the function describe year for the year 2014. And so now I can see crime for the year 2014. I have convictions against burrow for 2014. If I want to do 2015, right, just type in 2015. Again, it's going to take a second, right, because it's Spark. It's analyzing quite a bit of data to filter through, you know, those 13 million records. Burrow, sum, again, pulling the local iterator. Now for 2015, we see it looks pretty similar to 2014 Westminster. Is still the spike, but you get what I'm saying. So anyways, guys, I appreciate your time. Hope you learned some neat stuff. Have a good day. Thanks. Bye.